Okay, we have a nice session today. Over the last few years, we've probably seen the sort of growth of an interest in IT, in the IT as opposed to just the data center. I find it interesting we spend so long optimizing the data center and not really talking about the IT. And from a sustainability perspective, you have to consider everything. So in this session, we're going to talk about the drivers of IT efficiency. We're going to actually define it. It's surprisingly difficult to define. And then we're going to talk quite a lot about the opportunities that exist for efficiencies before we dive into the difficulties in practically applying them, or some of the sort of case studies from our panel. And then, if we have time, maybe some of the future opportunities. So let's start. Could I ask the panel to introduce themselves? We'll start with Etienne.
Yeah, okay, my name is Etienne Guerou. I'm working with a Kiwi company called PowerShield. I've been in UPS industry mainly for about 30 years. So I think that efficiency always been a topic for us, mainly when designing and helping designing data centers. And now I'm on the battery side, because battery is key, battery is power. Without battery, no data centers. So it's all about efficiency and sustainability as well.
Thanks. Hi, Vanessa Moffat. I'm General Manager for QIO Data Centres. And I've been in the industry 15 to 20 years, and I've been working for lots of different companies in the industry. But generally, you might know me from DSIM, from being involved in the DSIM side of things. And it's all about the building and the IT working together. So that's really where I'm coming from.
Hello, my name's Deborah Andrews. My actual title is Professor of Design for Sustainability and Circularity. So I come from initially a product design background. I've been working with the data center industry for over 10 years. We carried out a PhD program some time ago, and we did the first ever integrated full life cycle assessment of a data center, which included the building and all the IT equipment inside. And one of my sort of passions, I suppose, is the fact that embodied impacts are generally misunderstood and ignored. So I hope to explain a little bit more about that this afternoon.
Hi everyone, my name is Ben Tung. I'm the Digital Net Zero Lead in NHS England. So my role across the whole of the NHS looks at what we can do to encourage colleagues to think about sustainability when they're buying IT products and services, building and running at national health apps and data services, and how we can support the frontline healthcare delivery network to think about embedding some of this stuff, some of the easier stuff.
Hello, I'm Gkenakou from Prosperia Consulting. I help businesses in the data center world develop ESG strategies and align their supply chains to implement them.
Excellent. So Eva, I'd like to start with you. What's driving the need? What is the environment? What's the context around IT efficiency?
Yes, I was in the previous panel as well, so I'm probably going to repeat some of what I said before, but looking at the bigger picture, we are facing an existential threat for humanity at the moment, and that is driving quite a lot of the efforts that are that businesses are making at the moment. And together with that, or to help with that, there is quite a lot of regulation and legislation at the moment around climate and carbon, and what is zero carbon or net zero carbon, as per the title of the panel, and what that entails, I guess, in data centers. It would be things around green power, energy and water efficiency, but also the equipment in the data centers. that needs to be low carbon, water efficient, and so on. And we have a number of regulations and legislation that looks at various aspects, like energy efficiency targets, carbon targets, water targets, but also things around the circularity and the resource management of the products and the materials, and also making all of that much more transparent through regulations and legislation to do with tracking data and reporting, and not only reporting your own operational data, in essence, collecting and being responsible for reporting and due diligence to do with your supply chains as well.
Yeah, in my experience as well, it's exactly that drive to report, not necessarily what you're in control of, but what you have influence of, right? The scope 1, 2, and 3, and there's almost no hiding it. I want to bring Deborah in. Many people in this room would define hardware efficiency as operational energy efficiency, but it's more than that, isn't it?
Yeah, very definitely. I mean, if you think, I don't know if anybody has any idea at all how many servers there are in the world, but there must be trillions. And if you think they weigh, 25 kilos each? An awful lot of that mass is steel, but there are many other materials as well, aluminium, copper, lots of critical raw materials in the circuit boards, etc. So when you are looking at operational energy, that's fine, but it ignores hardware completely. And I'm sorry that I missed the beginning of the previous panel, because I think there are some similarities and points about embodied impacts and so forth, and what is and isn't measured. But at the moment, we've got a huge problem with hardware. The impact of hardware is not being measured and assessed properly. There are some embodied carbon assessments, but they ignore the majority of really key indicators that give you a true picture of the impact of a particular product. And servers, especially, they, and it was identified by the EU a number of years ago with Lot 9 and what have you, that they, out of all data center equipment, hardware side, and beyond, well, if we think of M&E as sort of infrastructure related, this is IT, etc. equipment, they have the highest impact. And there are, I can't remember, 69 plus different materials in a typical server. They have really large circuit boards, and none of that material other than anything with iron, copper, aluminium, or gold is recycled. We're losing a huge array of different materials to landfill or incineration or what have you. And none of this is considered because there aren't, apart from the project that I lead, joke, there aren't decent metrics to present information to end users in order to inform decisions very well.
Right, and Vanessa, what are some of those metrics?
So we've got, or under the Paris Climate Agreement, there's an awful lot of legislation coming in, and so we've got ISO 30134, which has got EN 5600 metrics in it. It's not just PUE. We spent so much time focusing on the building that we need to start focusing on everything else. One metric on its own won't give you the efficiency of a data center. So what these are bringing in is a number of different metrics. It's water, it's carbon, it's reusable energy. It's 2 metrics for IT, so IT energy efficiency and IT energy usage. And those 2 things are going to be very difficult to measure, I think, because we haven't really focused on the IT. But we need to, because that's where the efficiencies are going to come from.
And so if you're optimizing for that suite of metrics and they're all improving, you're probably doing something right. You're probably not caught in a sort of tunnel vision, optimizing one and compromising the others.
Yeah, exactly.
And so now into the sort of the core of the discussion, what are some of the opportunities for hardware efficiencies? What are some of the things that you've been doing, Vanessa, with QIO?
So we've got an AI solution. I think maybe AI might be part of the future set of tools that we actually bring into play to manage some of this, because there's an awful lot of data to gather and an awful lot of data to analyse. So ours is data center, kind of it encompasses the whole of the data center, but uniquely it touches on those two metrics, those two IT metrics. And so we can help, we actually set the chips into sleep states so that we reduce the amount of energy consumed by the servers. And so I think, you know, a lot of people have been talking about sleep states, so finding a way to actually leverage that. It's already there, it's already embedded in the chipsets, but it's just actually controlling the chips and taking advantage of it.
And what's the sort of, how in percentage terms, how much energy can you save?
In our experience, up to 50%, just from the servers.
And Etienne, I'd like to bring you in on utilization rates in servers.
Yeah, it would be, on my side, would be more on a product basis, I would say. When you look at the infrastructure in your data centers, it's in fact only to power IT. If you reduce the consumption of IT, then you reduce everything else. But there is a second thing as well in design, I think we have been discussing a little bit. We're using too much of legacy design, them as N+2 on UPSs, which means that you have double batteries, double UPS, double losses. But if you look at the failure rate of those units, it's very, very minor. And all those UPS now are modular, so you can add any modules you want by just reducing the design. As those guys in UPS, we have double supply directly at the UPS. So you will just remove a lot of equipment that are just losses for nothing. And I've been participating to other panels before, discussing about water cool. What are the savings you can have? A lot. It's amazing. We are monitoring batteries and seeing how much, how the battery are badly used, and all the charging, discharging, and recharging, and discharging, and charging again and again and again. It's all of losses, and you have to cool all that. You have to air cool everything. And I like very much what the other French guy was saying. What do you prefer, to cool the champagne, cooling the room, or cooling the champagne? I find it very, very simple things. And so the point is how you use the power and why are you using it for, and ask yourself the questions. Am I doing the right design? Finally, with all the technology we have, and I would say efficiency, quality of equipment. And the second one will be on power saving, battery charging, for example, these kind of things, or UPS. I've been in UPS for a long time. I go in every site and the UPS are charged at what, 30%? And people say, oh, we need the big design. We need, we need to be careful. But reduce the power usage by your IT, and then you reduce the UPS, and it's all cascading down, and it will just reduce the consumption. So focus a bit more on equipment, and it will be good.
Right, and so a lot of the things you mentioned there, so utilization, right sizing, all sorts of things, but a lot of that is the operational phase. Deborah, I want to bring you back in terms of the design phase of a lot of this hardware.
Yeah, I think, when you look at how rapidly the data center industry has developed, it's absolutely unprecedented. The scale, the speed, etc., is absolutely unprecedented. And everybody's been running very hard on the spot to keep everything going. And so there's been a very linear approach to the design of products where, the emphasis is being, if there's a problem, you develop a micro tweak to resolve that problem. There's never been any return to first principles to look at what equipment actually has to do. So you're sort of building on perhaps faults in the design. We need to stop doing that and just pause for a minute and look at the design, and to think not just about designing for the here and now to make this product function for the next year or 2 years, whatever, but begin to think about, well, what's going to happen to it at end of life, for example, or how can we keep products in service for longer, extend life by making repair and refurbishment, etc., very economically viable, rapid, effective, and so forth. And also thinking ahead again, not just when I finish using this piece of equipment, somebody comes along to the data center door with a lorry and it disappears, and that's it. I don't have to think about it anymore. But consider how on earth we can design for materials to be recycled back into the system again and develop closed loops. there's a lot of potential for that. It's just, we almost need to just stop for a few minutes and really consider what's going to happen in the future to all of the equipment and change the way we approach design.
Ben, I want to bring you in on some of the maybe the challenges you've had or the successes you've had practically applying some of these efficiencies.
Thanks, Mo. Yeah. So my context is quite different to the rest of the panel and probably the rest of the conversation. Apologies, I only arrived just a few minutes ago. But so I'm a technical SME in a very, very large public sector organisation, but a team of one, trying to kind of think about how to encourage colleagues to embed this stuff. So there's loads of stuff we could do, obviously, but in terms of practical application, the first stage is getting buy-in. How do you tell stories that get people involved? The single fact that I think is most poignant that I've heard for this comes from How Bad Are Bananas by Mike Berners-Lee, which is that you'd have to run a smartphone for 34 years to draw the same amount of electricity out of the wall as it takes to manufacture it, which is a bit of a wow fact for me. So, how do you get people interested is the first bit. And then what levers have we got? We've got the tech code of practice, which ties into spend controls. So everything we do, we have to show that we've done sustainably. So we've got that in black and white. That's great. Not as rigorous as it should be, I think, but it's there. So we've developed some tooling, low carbon design tooling for digital health applications. The next big step for that is to boil it down profession by profession for different digital professions to know what they should do, because they've got loads of other stuff they need to do. So how do we get them focused on 5 actions that they could do in their world is the next bit. If anyone wants to collaborate on that, I'd love to talk to you. Barriers-wise, maybe how do we prioritise this topic? I was really interested to see in the Green Software Foundation's State of Green Software report that came out recently, the respondents to that put sustainability 3rd in the order of digital design objectives, which is actually way higher than I perceive it to be for most people, but that might just be the kind of people who responded to the survey. But how do you get it up there? How do you manage trade-off with other things that people think is more important, and how do you develop skills? Like the whole DDAT skills, digital and data skills piece across government is really important. And opportunities like, can we frame it as cost savings? Definitely, with things like cloud hosting, green ops versus FinOps, or not versus, with FinOps. And, how can we start to think more holistically about those design objectives and map them into one kind of web rather than single siloed topics? And we're starting just to play around that a bit with our service designers, people who are designing web interfaces for client engagement purposes for digital health stuff. So bringing different colleagues from cyber perspectives or interoperability, whatever it might be, so along with sustainability people. So that's my challenge, is boiling down this technical stuff into what do you actually do about it in a large, complex place.
Mm-hmm. And Etienne, how do you manage these trade-offs, right? Because you've got people being pulled in different directions, performance objectives, cost objectives. How do you balance the environmental or energy efficiency objective within that?
It's a very large question. I think that it's all about economics. When you are outside, you say, oh, everything has to be green, energy saving and everything. But as soon as you walk in the room with investors, you talk about economics and profits. So I was in various panel and think that unless we have strong regulations that push people to do things, and I was hearing about Switzerland in 2030, they will have to be neutral for every building. This is kind of regulation that will help to push the people to take actions, sadly, not realizing that sometimes doing a bit less would be better and not always more and more and more. So I think it's a trade-off. Should we talk about renewable or carbon footprint? What's mean renewable? Those big windmills that you see over there. I've been working for a very large corporate. I know how we manufacture them. And I tell you that the carbon footprint of those big windmills is not very good. But they are renewable. It's green. It's fantastic. So it's all about stepping back, is what I heard, on the aging of goods. Should we buy new equipment more efficient, or continue to run the old equipment that even the losses they have will be less in the carbon footprint of new equipment? Will we accept to work with old equipment? And so forth. So it's a lot of questions that I don't have reply, but I don't have answers. But if we don't step back and ask ourselves, what PUE, fantastic. What does that mean, PUE? It's not really the point. It's what your IT deliver. This is the point. And how much energy you use to deliver your IT calculations. This is the point. It's not PUE. PUE is fine, but when you're air cooling, and I know quite well about it, been working with some of them, energy consumptions. My PUE is 1.08. Fantastic. Yeah, but my servers are still very hot. Yeah, but everything's working fine. So, come back to your point is renewable or carbon footprint, true carbon footprint calculations from day one to end of life. And I think end of life and recycling is very key. And until regulation will not be there, people won't do anything.
Interesting.
I'm sorry to be just...
Please.
Can I pick up on a point that you made? So you're talking about comparing the operational efficiency of an old server versus a new server, but in that we're not including the scope 3, are we? So at the moment, we still don't really know.
Yeah, agreed.
So I think it's just an interesting point.
Things to be done.
Definitely.
So one of the things we have worked on is KPIs. So it's similar to the suite of metrics you talked about, but actually relating it to the business value. So for example, with Spotify, emissions per streamed hour, right? It's emissions, it's an environmental per functional unit or business unit. And that is it aligns a lot of the technical silos, the data center, the IT, the software, right? And then you don't lose, we've got a terrible emissions per streamed hour, but we have a great PUE. It's very difficult to hide. The problem with that is there's no one metric. So we mentioned emissions per streamed hour, but what about critical resource consumption? What about water consumption? So this is, I think the difficulty is that it's always almost a big game of whack-a-mole, and it is trade-offs. I wonder, Eva, if you've had experience with some of your clients.
Yes, I think anyone that is trying to work on taking tangible action will have come across these dilemmas. And I think that's why it's important to take a structured approach that would be based on some of the standards, either existing ones or new ones that were mentioned earlier, that have exactly that as a goal to be quite holistic and look at all aspects of environmental impacts, even social impacts, we shouldn't forget, and all parts of the life cycle as well, like was mentioned before. So there are ways that this can be done through life cycle assessments, for example, either carbon focused or environmental ones, and it is part of I would say, can fit any role in the value chain, either to request them or offer them to clients or get the skills to be able to deliver them. So we have more data to make more informed decisions. And I think what is very important, that is not a big innovation, but can sometimes be demanding, is do what we know is right, to break down the silos and work with all the parts of our value chain, work with the customers, work with the suppliers, work with the designers, to really challenge the status quo and the business as usual, what we have, like from momentum, rather, and really look at the specific task in hand and what the best solution is for the particular project, the particular geography that we were saying before, and use new thinking, but also old thinking. How can we repurpose something that we have been using? And there is quite a lot of talk now about repairability, and it is part of the avalanche of regulation now coming that is trying to take our thinking towards a more circular supply chain model, and not a linear one necessarily, where bits and parts can be taken apart and upgraded or repaired to help utilize some of those critical raw materials that Deborah, for example, mentioned. And the good thing is that with that we see a further development of the ecosystem around the reuse or the circularity of equipment, hardware as well. And for example, I have a customer that is using Circular, which is a data center marketplace for used equipment to find a new home for some of the equipment that they need there. And I know there are other players, but this is an example. I have a recent example.
Excellent. Etienne, I'd like to bring you in. We've talked about utilization rates, we've talked about basically best practices. What are the future opportunities, or what are the near future opportunities within the hardware efficiency space?
What a question. I'd love to get the answers. I think that few of you have followed the other panels. I think that water cool, definitively one of them. I think focus on recycling, making IT equipment a bit more resilient would be good. AI will be something that will certainly shake the tree, because it will require so much more power. Yeah. So what do we do? New nuclear plants, is it good, is it bad? If we are talking about renewable, and I know it's not very much efficiency, but in Australia at the moment they got 50 million solar panels to recycle. They don't know what to do with, because they're using the old silicon technology. They don't know what to do with. 50 million panels. For what? Because it was green energy. Fantastic, yeah, good. But look what it generates as waste. So I think that I'll go back with Deborah was saying, we have to look at the life of equipment. I think this will be part of efficiency as well. So we can't just talk about consume less, PUE 1 or whatever. So solutions will be definitely sit back, look at the design. Is the legacy of design we had with N+2, dual feed, all this plenum and ventilation that goes through the data center. Is it what we need to do?
Yeah.
Can we change the mind of people?
Interesting. I think for me personally, I think two interesting areas are, we've got sort of CPU, GPU, TPU. It seems that the chips are sort of specializing to match the workload. And I actually think we also have that in the data center space, with edge data centers, cloud, centralized, the whole IT chain, the stack, is in many ways, in my opinion, moving to match different workloads, which is quite a good thing, because it means it's not a one-size-fits-all average. It means that specialization, I think, will bring efficiency. I want to, last question, I think Dan maybe wants to ask a question, but to Deborah and then maybe to Eva, the importance of procurement, actually, and also to Ben, as it's applied, right? So the importance of procurement in the life cycle.
Yeah, obviously there's a lot of pressure from OEMs because they want everybody to buy new equipment. But if you are being prudent, you should really investigate whether you need new equipment, whether you can upgrade your current equipment. I think there's a need for sort of training, etc., to overcome some of the barriers or misconceptions about secondary equipment, much of which might not meet the high-ranking performer or businesses' needs, but certainly would meet business needs of operators who have slightly lower requirements. So extending product life is absolutely essential, but we do need to overcome a lot of prejudice and barriers about secondary equipment. And interestingly, Ben, I know the Green Public Procurement Plan was something that was developed fairly recently to encourage and I don't know whether it's mandatory, but certainly to encourage public services to buy secondary market equipment which will meet their needs. That's really important, because if you buy new, what's going to happen to stuff that you're getting rid of? We don't have a recycling infrastructure to process anything like a millionth of the equipment that's already e-waste that's already around, and we're continually feeding into the e-waste stream. It's the fastest growing global waste stream in the world, and we are literally wasting millions of pounds, dollars, yen, or whatever of equipment and resources, etc. So I think consider very carefully your requirements as a business, and don't simply be seduced by men in shiny suits who want to sell you new stuff. No.
Etienne,
Yeah, the one thing about efficiency that it depends the scope of measure. If you measure just the equipment you have, it's 98%, very good. But what we should measure really is same as what I was talking about, carbon footprint, is how much energy do you need to produce it? And then how much energy you will use it during the life. And the longer you use it, the lesser the energy you use, and everything you use to manufacture it will have an impact. So that means, and it's a cost. Very often we come back and say, oh yeah, but this one is cheaper than this one. And on the paper, I've been on the side of equipment seller. So I've been doing marketing a lot and explaining people that, oh, my spec is comply with your requirements.
Can I just interrupt, please? Yes. So one of the things that Deborah mentioned to me when we were talking was about this, I can't remember the name of the guy, but how we design things and how we've designed things since the 30s, was it?
Oh, you mean about planned obsolescence?
Yeah.
Yeah.
So everything that we do is with planned obsolescence in mind, right? So the whole manufacturing process, historically, from a social perspective, has been geared around making sure you can't continue to use it, right? So there needs to be some kind of pressure made on that, a fundamental change in that thought process, because if the vendors are making it to replace components instead of the whole thing, or they've got a whole change in the manufacturing process, then it will drive, because as you said, if you look at recycling, I mean, I go to my dump and they won't even take, a computer. Do you know what I mean? They look at me funny and think, what are we going to do with that? So we don't have the ability to recycle this stuff. So how can we put more pressure on the IT manufacturers to move away from planned obsolescence and get much more efficient in how we can repurpose kit, because it's difficult, isn't it?
Yeah.
If I may, Dan, in France we have one thing now that it's compulsory. It's a self-declaration, but it will become something compulsory. You have to put a score on how you can repair and fix your equipment. And when people go and buy stuff, they can see the score, and the higher the score, the easier it is to fix.
Yeah.
And
that's on the right direction, but it's still not changing this planned obsolescence, right?
Yeah, but you can fix it.
Because if we're trying to move to a circular economy, we're trying to move to a circular economy with equipment that's not designed to be circular, which makes it pretty impossible, right? So how can big users like the NHS, all of us as data center operators, put much more pressure on the equipment manufacturers to move away from this kind of design thought process?
I think that there's other industries are doing it already, but in fact, I think Rolls-Royce have been doing it for over 50 years. Rather than selling engines for planes, they sell power by the hour. So they maintain, they lease the engines to airline fleets, and they maintain them to ensure 100% plus performance, etc. That sort of thinking needs to permeate other markets, like, for instance, data center. Instead of selling pieces of equipment, could we not sell, and it wouldn't be PUE, it would be some new metric that is invented or devised to cover lots of different performance criteria.
They actually use our software to do that.
Oh, okay.
Yeah.
Okay,
It's
right,
very
sorry.
cool. So there's AI.
Very
Cool. No, but they use our parks algorithm, and it's all about extending the life cycle of the product.
Yeah,
So,
but leasing models as well rather so that manufacturers become responsible for the stuff that they produce, sell, and make huge profits out of. At the moment, there's a sort of a lack of responsibility for products, so maybe manufacturers need to take more responsibility. That could be a good driver. And I don't know whether carrots is the answer or sticks, and unfortunately I've got a feeling it might be sticks and legislation.
There are equipment vendors out there that are driving sale of recertified hardware. I mean,
Yeah.
there's
TechBuyer.
TechBuyer,
Yeah.
and Servero's one that
Yeah.
sells recertified Supermicro kit. And in fact, they won't. Some of these people, they're not even interested in selling new kit because
Yeah.
they can't make the same. They can make more margin on selling the recertified kit than they can on the new kit. So there is an economic model that works, but we just have to try and support it and adopt it. And I think what drove it more was the delivery times for new gear, right? So during COVID, all the delivery times went up. So people didn't have any choice. They had to buy recertified hardware, realised it worked as good as the new stuff, and it was more economical, and that's kind of shifted a little bit. We are at the end of this session.
Too short.
I know. We're at the
Too
end.
much
We have got one more session left. I've got the beers out early. So there is alcohol in the exhibition floor, which always helps kind of excite things at the end of an event. So we'll be reconvening, I think, in about 10, 15 minutes for the last session, hopefully drawing some conclusions. Ben is back, some other people are back, and please join us for the last session if you can. Thank you very much, panel. Thank you, Mike.